Guys hear me okay? I think so. Great to see everybody here at AWE. Appreciate you guys all coming out. Brian Hamilton, Head of Marketing and Sales for DigiLens. Been in the space for a long time, been a repeat founder in the space, and had some great wins and also some great learnings through the process. I'd like to introduce Chris Hample. Chris, would you like to introduce yourself?
Yeah, hi everyone. Good afternoon. Chris Hample, I work for Booz Allen Hamilton. I'm the Director of Spatial Computing as part of our Chief Technology Office, kind of Bright Labs, kind of R&D type organization inside of Booz Allen. So thanks for having me today.
Great. So today, we'd love to get some questions at the end, so we're going to try to power through the slides. But basically, we're here to talk to you about the XR ecosystem, merging to Indispensable. How do we all get there and actually scale? Before we begin, I just wanted to point out why is DigiLens on stage with Booz Allen. We're doing a partnership with Booz Allen. It's very important as we look at the deployments and the utilization of XR devices that we look at full stack integration for everything that we do. So it takes a really great systems integrator and partner like Booz Allen to really look at the full stack of integration opportunities. Also, as you guys might know, Booz Allen is very famous for their government work. So the opportunity to work with the government and understand what the government's needs also translates, those unique requirements also translate to enterprise, industrial, and you have to actually look at the full solution for the problem. Last but not least, we need to actually build out a robust set of solutions for the ecosystem, and that includes a lot of different types of scenarios with these types of devices that are out there for XR, which include managed services, IT integration, software integration, sensor integration. So it takes a really great partner like a Booz Allen to be able to be at the table with us. So let me tell you a little bit about DigiLens. First off, just want to highlight that DigiLens, if you haven't heard of us, is a company that's been around for 15 years. It's backed by some of the industry leaders like Samsung Mobile, Continental, In-Q-Tel, Universal Display, Panasonic, Mitsubishi Chemical, and others. The beautiful thing about DigiLens is that the company's got a lot of flexibility. We're not just a device company. We do actually teach people. We're a waveguide component company at its core, which also now just translated out to a product company as well. So when you start thinking about XR devices and devices, we're kind of on an island by ourselves as a standalone XR device with the Argo platform right now. The opportunity is where we need to have a lot of flexibility to be able to understand the full optical stacks that go into these types of devices. We need to understand how they get implemented. And we also have to, that's part of the ecosystem. So it comes down to things like manufacturing and high yield manufacturing. The ability to have a cost point in these devices as part of your bill of materials cost. So DigiLens really does three things. Number one, waveguide company at its core. We work with the largest OEMs, ODMs in the world. We actually teach others on how to make waveguides using a photopolymer or a nanomaterial. So very different. We actually inkjet print our waveguides. We can change the structures. Some of the biggest flexibility for optical stacks in the market today. So you have that component. Because if you don't have the lens of the future, you won't have the device of the future. Number two, light engines. Well, we have some great partners that we're agnostic on light engines, but we also actually build our own light engines as well because we're trying to retrofit a lot of the light engines that are out there in the market. So we actually can be very flexible on light engines, but also had developed our own light engines as part of our optical stack. Number three, as we get into ecosystem, we all talk about chips. Chips are very important. We have great partnership with Qualcomm. We're actually one of the few companies in the world that has a source code level access for chips for XR devices. So being able to work with XR1, XR2, AR1, AR2, we can actually get to the source code level, which allows us to be able to look at things like heat dissipation, battery life, those kind of things. So we have glasses, the ability to customize glasses, and also the waveguide business. So really important evolution of the AR and XR space. It is kind of a Moore's law, and we are entering into the next evolution. It is happening. One of the biggest reasons why we know it's happening is because a few years ago, if you had asked me how you go to market, it was going with many, many different ISVs and independent software vendors and putting as much applications on the device as possible. Today's world is about getting deep with your solution integration partners like Booz Allen and others, where you're actually building the complete solution for these XR devices. Ori stole some of this morning in his opening, but we have to study the future or study the past to really understand the future. So, when you take a look at the space, there's been a lot of different devices with different classifications. You have to study the past to understand what's going to happen in the future. And everything's pointing to the spatial computing opportunities. So, for example, natural language processing. We just announced a partnership, thanks to our friends at Google here sitting in the room. Google just announced that Gemini on Argo, which is our product, it's the first all-in-one AR device that's AI-enabled. And we did it with Gemini and with Google. And we're very proud of that. And if you come by our booth 427, we'd love to show you how you can just literally do a natural language kind of exercise with the device. Also, the opportunity for gesture recognition and the opportunity for AI-enabled XR devices with being able to have seamless intuitive controls for virtual objects and controls. So as an industry, one of the big lessons learned as we look over the history of the space is that we need to understand what's happened in the past, how do we build utilization, what are the KPIs, what are the use cases, and we need to quickly as a group, not just one company, get out of POC purgatory and get into something that's actually meaningful together.
Yeah, hey Brian, if I could just double down on that real quick.
Please.
On that last slide was, I'm sure all of us too have, a bit of impatience with this. We're trying to deliver full solutions out to customers. And because we see and realize the benefits that these technologies can provide, but we have to get to the devices that have the right form factor, that have the right battery usage, that can take somebody like, not in a lab, but going out in the field and dropping it on the ground or smashing up against something, and it has to be still work. So I think a lot of from our side, really thinking of the solutions and use case at Booz is we're so anxious for these kind of headsets and impatient to get to this stage that we're finally at now. And that's kind of one of the reasons why we're up here partnered with DigiLens is trying to get to that stage. And I'm sure we all feel it.
Great. And so there's a lot of problems that are facing the space today. And again, no disrespect to any device creators out there. There's not as one size fits all. If you ask me, there's many different devices for many different classifications of use cases. But some of the universal challenges that we're seeing out there is form factor. With the Argo glasses that we have, it's a true pair of lightweight glasses. So being able to have something that you can wear for an extended period of time, weight and size, social acceptability. One of the things that we've been really working on with our waveguide technology is the ability to have transparency. If you're engaging with somebody in a headset, you need to be able to see their eye. You need to be able to interact with them. You need to know that they're a human and they're looking back at you and they're not just closing their eyes behind a device. Efficiency. One of the biggest challenges in waveguides that we've been working on is what we call eye glow. So if you have somebody working on a truck at night, you can't have them lit up like a Christmas tree. You got to have an opportunity to have the light, maximization of the light come to your eye the right way so that you get work in all environments, indoor, outdoor, and everything in between. And then also, last but not least, which is not a function of a product, but it's the actual ability to do manufacturing of these types of devices. Very difficult. You might see the most amazing reference design in the world, but if you ever have created a product in this room, you know it's super hard. So you've got to be able to manufacture the components, control your supply chain, and that's what we do with our process with being able to control the entire optical stack, which is over 85% yields, which all starts in the waveguide manufacturing for our products and for our partners' products, which we do partner on. Ori stole this morning, I'm just kidding, but in 1968, we talk about the first heads-up displays, human-machine interface is born. Some of the key use cases that we're seeing in XR that we're using with these devices are the remote expert capabilities, the digital twin, the ability to do dynamic workflow. I see our great partners, I think we're in the room from Tactile here, the amazing workflow system. So being able to do the ability to have digital workflow and be able to understand that training. Just to show you here, this is one of the first remote mentor use cases from the 1960s. They're working on, simultaneously working on a problem, and it's simply just launching a camera and working off the same data sets in 2 different locations. And so and then here's work instructions from the 1980s as we think about maintenance, repair, and operations, and some of those types of things. So the lesson learned is we have come a long way, but we're still doing use cases that we thought of over 65, 70 years ago, which is pretty fascinating. Turn it over to Chris here to talk about the DoD space and the government space, because I think there's a lot of lessons learned. Please.
Sure. Just sit. I'll just sit here.
I mean, whatever you're.
So we've seen a big adoption both. We see a lot of DoD pictures, but here broadly across federal government too. Early 2000s, definitely exploration, structured programs, a lot of big system type modeling and simulation systems that would be integrated with. You'd have some like flight trainers, that sort of approach. Things have keep evolving, wider adoption, 2010s, 2015s. You saw much bigger programs come out, a number of programs, especially from the Navy side and government side. 2015s, 2020s, the really expansion. Now we start seeing the like the IVAS program, the initial IVAS program came out, and what the government's looking for, greater introduction, and then now adding much more AI and acceleration. I think broadly though, across these, what really we've seen is, like we're all seeing, is a move from prototypes to fuller scale at points, spot areas where the use cases really call for it. So like pilot training and collecting analytics on pilots, increasing the number of students per trainer. That is happening with a lot of these use cases. We're seeing that. I think what we're seeing now is like, okay, that's great in these spot use cases, but all of these applications and XR needs to be part of a bigger solution. So what's the edge compute? How do you wrap that in the analytics? How do you wrap that into the training systems? How do you integrate that into the network more completely? How do we deliver full solutions instead of just like a prototype example we're showing in a lab? How do I take digital twins and integrate those into these devices, both as a sensor and a display device that is part of that? And then most recently, definitely the expansion of AI. And we'll talk a little more about that. But like, how do you, that intersection of AI and bringing that to the edge versus a lot of the models we see today, which is, you know, in the cloud, on the computer. How do we keep it real time at the edge and empower individuals? So a big swath of adoption. We're definitely in Booz, which most of our work is with the federal government. You know, you've seen the uptick. What's interesting is you've actually, if you look at proposals or RFPs of, you know, the organizations put out asking for responses that we'll come back and create a solution for and respond to. You've seen this uptick where people weren't naming XR, VR, AR, and then suddenly it's in everything, and then now we don't see it as much because it's part of a solution. You'll get like broad metrics, but we see it being asked for, like included in the same way you think of mobile, you know, in a lot of aspects. It's really been that maturation process. We're not there yet completely, but definitely matured greatly. Oh, yes, so on one of the areas, and we'll get to some use cases too to really kind of dig in to see how this all applies and where we brought it together. But I did want to bring up 5G and XR, especially when it comes to the sense of headsets. 5G is definitely, we often think of it as, you know, the ads on TV with, you know, high bandwidth, low latency. And you see these part of these three aspects of enhanced mobile broadband, massive machine types communications, and ultra reliable low latency. Those are components of it, and that's what's being delivered. But what's often overlooked is the bunch of services that 5G also enables. And so we've been working with really applying that. Two examples here are network exposure functions and network slicing. So this is, we'll show an example where what it's really allowing you to do, instead of, in addition to the high bandwidth, is now I can prioritize different applications. So I'm able at the application level to take one application and say, hey, this is a medical use case. We need to take all the bandwidth and move over to this application. With the 5G setups and these standards, I'm able to do that. We've done some examples for mobile medics in that case. So there's just, I'm bringing this up because there's a lot of power in what's happening. And Brian, maybe on the next one too, just to kind of hammer that home. Here are the standards for 3GPP. If you haven't looked at these releases, for this field, it is very relevant. You can just see listed out, release 18, so there's a standard freeze Friday on this. You can see the amount of XR services and protocols that are kind of getting laid out in there. So it's really just a shout out for y'all to to really start thinking about this. And I know 5G had the hype and then this kind of fall off where it's a little quiet, but there is some, once we're starting to make this more real, there's some real relevant functions and capabilities for our industry. So kind of going with that, where we've seen, and especially for devices like the DigiLens headset is, I mentioned earlier, we want rugged, long battery, we want a full kind of swap basically to be able to maximize. So we've definitely been exploring, you'll see a couple examples where we've done this with remote rendering. So how do we stream applications instead of running them on the headset? This helps us in a lot of areas too, kind of listing out some of them here, but includes just, as we kind of operationalize a lot of these things, it's a lot easier to manage, and it's much more secure. So if I have devices with applications running on them, and those fall into someone else's hands, that's a problem, So now the fact that I can stream that and I can push updates is a big factor for us. And then we can use the lightest headsets we can use and run it all remotely, use less battery on the device. So you'll see this theme of one of the areas we've been really focusing on. I'll go quickly through this. So this is an example we did with a client on delivery, very relevant to the example that Brian was giving earlier about early telementoring. So what we're seeing here is we're doing medical telementoring. So we worked with partners Tactile and HoloLight in this case. So we would take, for medical remote mentoring, we would have a headset on an individual, a mentee, who needed assistance with like something they just haven't been familiar with, procedure. So they would actually, through the scanning of that, create a digital twin. The remote mentor would see the twin, they would remotely telestrate it, and then the mentee would see that spatially anchored instructions and guidance on the body itself, on the patient itself. So much better than a cell phone call. So this was a great example. We used 5G over it. It really did call out as a need for a 5G native headset too. We went through every iteration, and there's an IEEE paper that's referenced in this deck that we could share that we published on the different combinations of dongles and headsets to really find out what worked best in this space for connecting to 5G over that. The second one also worked with DigiLens on, and also Tactile on, and NVIDIA, a client at Fort Cavazos, used to be Fort Hood, probably a little more familiar name, really doing, using and testing the effectiveness of XR and 5G for training in the field. So, instead of people being in a lab or an indoor room, let's get them out in the field and do a number of different training exercises. And let's try to understand how we can do remote rendering in these disparate, in the field, rugged environments and see it works. So definitely simpler headsets, lightweight headsets make a huge difference in getting, in this case, soldiers in the field and using them right away. We did have a lot of things here too around session management too. Like as you have people move between the field, you're remote rendering from a node out there, a 5G node. What happens when they go further and switch to the other node? How do you do these transfers? And this is an area I think we think AI can be play a role too to kind of help us with some of that smart transferring. But
yeah, great. So we'll give a couple questions here, but basically we're all here at AWE to make AR, XR, MR, whatever acronyms we want to use, we'll call it XR today. To be able to figure out how do we make it indispensable? How do we take the phenomenon of chat, GPT, and AI, bring it out of the computer, be able to put it in the headset of the future? How do we know we can rely on those types of devices just like we rely on our cell phones? How do we, if anybody leaves their house, they leave their cell phone, they turn around. Maybe leave your wallet at home, no problem, but your cell phone you turn around on. When will that happen for your AR or AI-enabled headset, right? And you've got a whole bunch of things that have to happen. Form factors, connectivity, integration with personal protective equipment, IT integration, 5G integration, AI integration now being the big driver. we have to do this as a village, not as individual companies. We really need to come together as an ecosystem and embrace each other in terms of not one company on the planet has the entire solution stack. So it really requires us to come together, understand where we all fit in the ecosystem, and then drive value and make sure that we can drive value for the partners that are actually commercializing this product. So with that, we'd love to pause and love to hear your questions. And Ansel's getting up. Okay.
Hi, Anshul from More Insights and Strategy. The question I had for you was related to the XR 5G applications.
Yes.
I extensively read the spec every release, so I really appreciate that you're putting it up there for people to see because there's a lot there.
Yes.
But in terms of these case studies that you've done, were these on commercial networks or were these on private networks?
No, they're on private networks. Yes.
And for private networks, are you saying what bands you were using? Like, was it CBRS? Was it like government bands? Like how was that utilized in the wireless spectrum?
Yeah, there were a number of different bands we tried in this case, and I can't go into complete detail on it. And I'm also not a 5G expert. I was more concerned about like, okay, what's the impact to the user, and let's measure that side of it. But happy to talk afterward on more details for that.
Thank you.
Yeah.
Then you got on-prem as well, very important for the integrations.
Hi.
Hey.
I'm an educator, and I'm wondering, the challenge with bringing this kind of tech to campuses is that IT usually has things clapped down for. Yeah. How do you deal with that? You already knew where I was going with that, so just take your answer.
Great question. We worked with a bunch of state and federal funded type programs, state programs for a lot of the universities. Great question, because you had to go through extensive audits on things. The key is to look at the solutions that you need to deploy in the classroom or in the environment, right? So, let's take, federal government, you need FedRAMP. In a classroom, you may need a specific type of integration with a learning management system or other type of system that you're already using. So the way we've done it is we've tried to take the lowest common denominator of compliance, both on the hardware and the software layer. So on the hardware layer, you need a device that when it hits the ground, it's going to stay intact, like our Argo device that's mil-spec'd and is a true ruggedized solution. On the software side, you've got to be able to work with the systems that are already approved by IT. Oftentimes, it's integration with Microsoft. So now that MRTK3 and 4 has been opened, working with some of the MDMs like Intune and others, we've been able to bypass some of the IT protocols for the beginning. So, but it's a very loaded question, because what you have to do is you don't solve just one thing. You have to solve many things. So you got to solve the software, you got to solve the integration, you got to solve how you're hosting it, you got to solve cloud, you got to solve connectivity, right? So that's why the market has changed and evolved, where system integrators are playing a much bigger role in actually making that a reality. So when we come knock on your university door, we're not just selling you a device, we're selling you a solution stack.
I'm Barry Ferris. I'm from Cable Labs, an innovation center for the cable industry, and been looking a lot at network requirements for the metaverse. With the MSF Metaverse Network Working Group and some others. And I want to talk a little bit about consumer. And I'm just always fascinated by the focus on 5G. I know the specs are there, they talk about it. Everybody's backing off on MEC and edge compute at this point. And the reality is that for devices out in the real world, not in isolated situations, 80% of the traffic is going over fixed networks to Wi-Fi. This is the place where things can happen a lot faster, specs aside. But Chimera and other ones are working on intent-based APIs for things that can help here. Just wonder if any comments on moving this out of these private networks and out into the real world.
Yeah, I can talk a little bit about it. I think one of the challenges we've had, yes, we're working in a lot of our clients have a slightly different environment. They're definitely been working as much as possible with the telecoms to be part of this. And you'll see like telecoms partnering on a lot of these opportunities and delivering that type of services. I mean, we've seen it happen with, even if it's a little more remote, so there's a bunch of different solutions that have been not at the edge, but in a public telecom environment that have been somewhat successful. I think it's a work in progress for a lot of those environments. I'm hoping, so a lot of what we were doing here is really trying to show, okay, how much does edge compute help? what is the difference on, is edge compute going to really make a difference or not? I know it's more secure, it's easier to maintain, but how do we kind of scale this out still remains a challenge. There's no question, and I think in the public sector, it's just going to take a little more time.
There's a supply-demand issue there right now. That's why one reason stuff's ending up on-prem, it can't be in the cloud, it's on-prem because there isn't an edge there to deal with it.
Yeah, I think too that, like you're touching on, the chicken and egg side, I mean, we don't have devices out in the wild and like big tranches of devices that are driving that. I know we all feel that and know that's the future, but we're just not there yet to drive the expense. But from the edge compute side, even if it's edge compute on, so we've done examples too, we've shown where we're doing augmented reality translation. So not going to the cloud, but using a DigiLens. We were demonstrating that recently. That's on a local device, so it's not a full edge compute like a big Cloud XR server or anything like that, but it is a small puck, and we're just running those translation services there. I think maybe my feeling is we're going to see more of that, especially as we inject more AI, small pucks, phone, and use those sort of tech to kind of, we got to relieve some of the processing off the device.
And also at the device level, and I know I'm out of time getting edged off stage, but I can tell you about how we look at it from a device perspective as well. Anything else? All right, happy AWE, everybody.
Thank you, gentlemen.
Thanks.
Thank you so much.